Welcome. So yes, I'm a specialist in galaxy evolution. And when I am sitting on an airplane and the person next to me says, "What do you do?" there's a brief moment where I have a choice. And I can either say astronomer or I can say astrophysicist. And in that moment, I look at them and then I choose based on whether I do or do not want to keep talking to them. I'm just being honest. When you say astrophysicist, it shuts down the conversation. They go, "Oh," and they go back to reading the in-flight magazine. When you say astronomer, they have follow-up questions. So I'm going to give you guys 15 seconds to talk to your neighbors and guess the 2 topics that people want to talk to me about on airplanes when I say that I'm an astronomer. You have 15 seconds. Go. Okay, let's see if you guys got it. The first one is aliens. I made the mistake one time of talking to the person next to me on the plane about aliens, and I will not do that again. The other thing people always want to talk to me about is black holes. So I don't work on aliens, but I do actually work on black holes. Okay, so what is a black hole? So a black hole is an object whose gravity is so strong that not even light can escape it. That's usually what I say when the person next to me says, "What's a black hole?" The more technical way to say this is the escape velocity of a black hole is faster than the speed of light. And what that means is that anything with mass has a gravitational pull, and if you're moving fast enough away from it, you can escape that gravitational pull. So here on Earth, if I was holding a ball and I threw it up, it would come back because I didn't throw it fast enough. But if you can throw it fast enough, which no human can, but a rocket, for example, is going fast enough that it actually escapes the gravitational pull of the Earth and can go out into the solar system. So for a black hole, the gravity is so strong that nothing can go fast enough to escape its gravitational pull, because you would have to go faster than the speed of light, and that's not possible. Just to stretch your brain a little bit more, there's another way to think about black holes, and this comes from Einstein and general relativity. So Einstein said that the presence of matter or mass literally bends space. Mass warps space, especially space-time. And so the mass around a black hole is so curved that nothing can escape. It essentially, you can think of it as like it curves back in on itself. It's just another way to think of it. Okay, I feel like I have to say this because there's this is a large misconception. Black holes are not cosmic vacuum cleaners. They don't just suck up everything near them, like a large vicinity. You have to get pretty close to a black hole to fall in and go past what's called the event horizon and not be able to escape its gravitational pull. Okay, so they have a lot of influence right where they are, but they don't influence things very, very far away in terms of their gravitational pull. Okay, generally speaking, there's 2 kinds of black holes. There's stellar mass black holes, the top line there. They have the mass of around the sun or a star. And we know how those are created. They're created by a massive star at the end of its life explodes in what's called a supernova, and the core collapses and leaves behind a black hole. So they have a mass of something like a star. And they're formed, they live throughout galaxies because stars live throughout galaxies. But it turns out there's another kind, and those are called supermassive black holes. And those are 1,000,000 to 1,000,000,000 times more massive than the other kinds of black holes. Those are only ever found at the very centers of galaxies. And we don't know how those formed. That's a very active area of research, is understanding how those formed. But they formed very early in the universe. Okay, so that was all background. So what do I study? So one of the things I study is how galaxies impact, or how black holes impact galaxies. So I study, first of all, which galaxies have supermassive black holes. People used to think, if you just go and look at the supermassive black holes and then the galaxies that they're in, they're massive galaxies. So they used to think a galaxy has to be pretty massive to have a supermassive black hole. That turns out not to be true. It's just harder to see the ones in lower mass galaxies, but they're there. So basically almost all galaxies have supermassive black holes just at their centers. I also study how those supermassive black holes are fueled. Black holes just secrete gas and dust and stars in their vicinity. But again, to really fuel them and to see so that they're what we call active, so you can see them, people used to think that you needed a very violent event And the common idea was that you needed two galaxies to literally merge and collide in space, and then that would funnel a lot of gas and dust down to the very center of the galaxy and fuel these supermassive black holes. Turns out that does happen, but most supermassive black holes are not fueled that way. It's a much more benign process. And then I also study what impact those supermassive black holes have on the galaxies that they live in. So this is why I wanted the lights a little lower. Hopefully you guys can see this. So on the left, here's an artist's impression of a supermassive black hole. This is not showing you the whole galaxy, it's just the black hole. Let's see if this has a, okay, so the black hole is the little black thing at the center there. This is an accretion disk. So there's a swirling disk of gas and dust and stars. And that's moving very, very quickly as stuff migrates towards the black hole. And then, this is hard to see, but there's also a jet going this way and that way. So some of the material falls in, some of it gets ejected out to very large scales. So these are actual supermassive black holes. It's hard to see the galaxy here. It's just a sphere of stars. And at the very center, you can see the bright thing. That's the supermassive black hole. Here's a jet coming out of that's reaching the whole scale of the galaxy. Okay, so it's impacting the galaxy on large scales. Here's a more normal galaxy that's a spiral galaxy, and you can't tell by eye, but there is a supermassive black hole at the center there. And I'm studying these kinds of galaxies and how those black holes are impacting the galaxy. It turns out they very often eject enormous amounts of gas and dust, not in these jets, but in these larger scale outflows. And then that impacts the galaxy's ability later to form new stars. Thanks.